Hi and welcome back. In this video we're going to look at how we can print our tree. And as part of printing our tree we're going to have to look at something called recursion. Recursion is something that can be quite tricky to really fully get your head around, but it's a very simple concept in fact. Something I'll say about recursion and also binary trees is that you won't be using these very often in your day jobs. I, for example, work in web development. I do a lot of sort of back-end development and front-end with JavaScript and so forth, back-end with Python. And I have never used binary trees or recursion in my day job. Nonetheless, it's something that can pop up in coding challenges, interviews, and so forth. So it's good to know about it. And it's also in software, it's used behind the scenes, like in databases and things like that. So it's useful to know about it. That's why we're sort of going through it. But don't worry too much about fully getting your head around all the use cases and how you use them extensively. It's just not really worth it. Although I will give you some more resources in case you're interested. In order to traverse in order, we are going to use recursion. So let's first in order recursive. I'll type out a wee method here. I'll type out a wee method and I'll explain exactly what's happening. And also, as part of this, I'll explain, of course, what recursion is, because I know that we've not done that yet. What we've done here in this inorder method is it doesn't take any arguments, but it calls another private method. In Python, by the way, I'm not sure if I've mentioned this, but when your methods and your variables start with an underscore, that means they're private, or you don't want other people calling them. So we call this private method inorder recursive with self.head as the argument. Self.head becomes current node in this inorder recursive method. So this inorder recursive method, all it's going to do is it's going to say, if the current node is none, then we're going to return. Okay, we're going to terminate the method. If a current node is none, we're going to terminate. Then what it's going to do is it's going to say call itself, but with current node dot left. Okay, so as you can see, this inorder recursive method calls itself. This is recursion. Recursion is when a method or a function calls itself. What happens when you call yourself is something rather interesting. And we're going to talk about it in just a moment. And then we're going to print the current node, and then we are going to call ourselves with the right node. Okay? So here's what happens when you do recursion. The inorder method calls self.inorder recursive. So we end up here. Now, Python knows that the inorder recursive method was called by the inorder method. It knows that. It keeps track of who called who. For example, so it can tell you in the stack traces in your errors. So it knows that the inorder method called us. We run through this, presumably we pass, and then we call ourselves again, inorder recursive. So we go back to the top. Now current node is a different node, but we know that we got called by inorder recursive. So Python knows inorder called inorder recursive called inorder recursive. Then we go again. If we call ourselves again, Python now starts constructing a collection of how did these calls go? Who called who? What were the arguments or the values of these parameters when each method was called? Okay. So eventually we reach the leftmost node of the tree. We print it out. Then we go right. And eventually we sort of are at the right or at the leftmost or at the rightmost node in the left branch of the tree, and we reach the end of the method. What happens then is the method returns control to whoever called it. So if inorder calls inorder recursive, and inorder recursive calls itself, that constructs a collection of method calls, and then when the method returns, we go back to the previous call. It's difficult to explain without actually looking at it. So what we're going to do is we are going to use this and debug it. So I'm going to set a wee breakpoint here before this method call happens, and we're going to go over to our app.py and print or do tree.inorder. Okay, we're going to call the inorder method here after we add a few nodes, and then in the binary tree file we're going to set a breakpoint in the inorder recursive function method. Then we're going to debug. Okay, now here begins the interesting part. And I'm going to try to go quite slowly with this because I know it's a tricky concept and probably my explanations haven't really helped so far. Here on the left, we're going to start looking at this main thread. It's not something we've looked at before in Python, but the main thread, now that you know a little bit about asynchronous programming and threads and so forth in Python, the main thread is really the thread that does stuff in Python. And here you can see that we don't have any other threads in this application. We've not launched any other threads. If you click any of these places, you'll be taken to where the call started for where you currently are. So we're currently here in this line, which is in our binary tree file, line 32. So here, the main thread tells us that we are inside the inorder recursive function in the binary tree.py file, line 32. And it tells us that this function was called by the inorder function. See, this is directly below where we currently are down here. So the inorder function, binary tree line 27, was who called us. And who called them? Well, it was app.py line 8. So if we go to app.py line 8, you can see that tree.inorder was called here. Who called app.py? Some Python stuff. The Python debugger execute file. Don't worry about that. For us, the execution started at app.py, then called inorder, and then called inorder recursive. The current node in this call is node 9. Okay, because that's the head that we called with. Now, we can go into this function. Let's go in by doing this, step into. Notice how now things changed. The current node for one is node 5, because that's current node.left as it was before. And now the main thread has changed. We are in the inorder recursive function, line 30. We were called by the inorder recursive function in line 32, this one here. And that was called by inorder, that was called by app.py. And one of the great things about PyCharm is that you can actually click on it. And when you click on it, you can see that the current node in here was node 9, the head. You click back to where we currently are, the current node is node 5. Okay? So, once again, let's step over. We go into this line again. Current node.left is none, and we know that. So let's step into once again. Notice how now we are in this recursive stack. By the way, this thing here is a stack because new things get pushed at the top. And we're going to see how they pop from the top as well. Now we are at the last call in this chain. Current node is now none because the current node in the previous execution had a left of none. So right now, current node is none. So what we do is we are going to just return. When we return, this method call terminates and we go back to the previous one. So notice how now we're going to jump down here, but this is going to disappear. See? The method call we were at before disappeared because that's the end of that call and we go back to where we were before. If we step into, Notice how it doesn't go into this method anymore because we've already ran that. Now it goes over to the print. Okay. Then we can go over to the next line. We can step into this line. And once again, we are at the inorder recursive method. But once again, the current node is none. If you check back, we're still at node 5 here. We're still at node 5 here. And all that's happened is the right was none. So when we called inorder recursive with the right node, that is none. So once again, we're going to return, and we end up back here. You know that when we reach the end of a method in Python, the end of a function, that returns. So as soon as we press step over, this function is going to terminate. Guess where we're going to go next? We're going to go back here. We're going to go back to the previous execution where the current node was 9. Okay, so I'm going to go back to where we currently are, press step over, and notice that's exactly what happens. And once again, if we press step into, this has already happened. We've already ran the inorder recursive function for the left node of current node. Notice how we're back at the top of our stack, and the current node is the head. So once again, we print, and then we go back into the inorder recursive onto the right branch. So current node now is node 11. Node 11 is the right node of the head. So going back to where we currently are, this is not going to happen. This is going to happen. We're going to go into the inorder recursive with a left. The left is none because we didn't add any more nodes. Once again, this is going to be none. This is going to return. And once again, we're going to go over to the right, which is also none. And that's just going to return. And now we have already, by the way, printed out our nodes because this print statement has happened there in between everything that's been going on. So now we're going to finish this method because we've already ran through the recursion. We are now at the end of the inorder recursive method with the head as current node. So when we press next, that is the end of the recursive method, and we can continue, and we reach the end of our program. This is recursion. Okay? And really important in recursion is you end up with that stack of method calls. And when one returns, it goes back to the previous call. So this is why we can sort of go deeper into our tree by going left and then left and then left and then left until we reach the end. And then it just goes back one by one. Really, please use the debugger to inspect and learn and play around with this because it's a tricky thing to get right. Recursion is difficult to get your head around. It's also not used all that often in what I'd call product-oriented software companies. But nonetheless, it's an interesting thing, and it's useful for things like these. I'd also like to give you a challenge. This code here prints the tree in order. I'd like to give you a challenge of printing the tree pre-order. So you can go ahead and do that. Try to print the tree pre-order, which is going to be a very similar piece of code, but just to give you a little bit more experience writing recursive code. Hopefully you got that. All you have to do if you want to write this in pre-order is, of course, move the print to before the other things happen. And then you end up with pre-order, and you have to, of course, change these names there as well. Okay. That's it for this video. Hopefully you enjoyed looking at recursion in PyCharm here, and looking at the in-order traversal of a tree. By the way, just before we finish, of course, if you just run the file, you end up with 5, 9, and 11 printed it in order, in order format. So again, that's it. Thank you for joining me, and I'll see you on the next one.